Oh my god, one time.
All right, my people, here we go. All right, so today we're looking at our third function in the series. Okay, so we've seen absolute value, we've seen quadratics. Now we're taking a look at square root functions. Okay, so building off of the activity that you guys did last Friday, right, where we did the Desmos activity, looking at how the square root behaves, right, trying to get familiar with the shape of the graph. Today we're going to formalize it, right, how to graph it, by hand. All right, so if you notice, right, it looks very familiar to what we've seen before, right? We have a, we have h, we have k. Now the big difference between the square root that is different from both the absolute value and the quadratic is that square root does not have a vertex, okay, because of the shape of the graph, right? The other two shapes were v's and u's, and you could see very clearly that it kind of had like a top and then or a bottom. In this case, we don't necessarily have that. We don't have a vertex, but we do have something similar to it in the sense that we have a starting point. And the starting point we can find by taking h and k, right? The same way, opposite key. Okay, so it's very familiar, very same process. Now, the difference, of course, is the shape, right? The shape of a square root function is almost like a parabola, right? Cut in half and then laying on its side, right? That's how I like to think about it. Okay, so that's a little bit about the general form there. Okay, any questions so far? It's still opposite key. Yeah, if we're looking for this point, which would be our starting point, right? So it's still important to find it. It's just we're not going to refer to it as a vertex anymore. Okay. All right. So let's take a look at the parent function. All right. So we saw this on last Friday as well. The parent function is essentially just the square root of x, right? It has no shift, no stretch, no reflections. Okay. So looking at the function the way that it is right now, would you be able to identify what the starting point is? Not necessarily. You could guess that it's what? It's probably 0, 0, just like it always is, right? Let's say if I were to rewrite this like I have before, if I were to take the square root of x minus 0 and then add 0 at the end, essentially I made no real change to it, right? So from here, right, we can see that, hey, this would be h, this would be k, so I could still now list my starting point as a 0, 0. Okay. So my starting point now is the first point that you'll use when you're drawing your table, right? So, right, the big difference was before when we had a vertex, we put the vertex point in the middle of the table. Now with the starting point, you want that to be your first one. Okay, so make a little note over here, call it SP, okay, your starting point, and that'll be the first point on your table, so 0, 0. Okay. So now, I want to pick values here to plug in for x. When you're working with the square root function, you really want to think ahead and try to think what numbers do I want to use for x so that when I plug them in, I actually know how to take the square root of it. Right? So an example is like, do you know the square root of 5? So don't use 5. Do you know the square root of 3? Don't use 3. Okay? So there's certain numbers that obviously you can type them into the calculator, you'll get decimals, but if you have the option to pick easy numbers to take square roots of, then pick those numbers. Right? So after 0, what would be a nice number to use? 4, what else? Even before 4. I heard it. 1, right? Let's use 1. If you use 1, what's the square root of 1? It's 1, okay? So you want to be strategic about what you use as an input. So we're going to take 1 and you're going to plug it in for your x value, okay? So now we'll get square root of 1, which is 1. Okay. Somebody said 2. Would 2 be a good idea? No, because the square root of 2 is like some decimal. It's like 1 point, I don't even know. 1.4, 1 point something? Yeah, something like that. Okay, so let's skip 2. Let's move on to the next one, which would be 4, right? Let's use 4. So now I take square root of 4, and the square root of 4 is 2. Okay, what's after 4? 16. Before 16? 9, right? So let's use 9. Square root of 9, we get 3. Right? And then after 9, we could use 16, right? Square root of 16, which is 4. Okay, typically with square root, if you can get 1, 2, 3, if you can get about 4 points, that's usually good enough. Okay, because then you get to really large numbers like x, and you're gonna have to make 16 all the way across. It tends not to fit. Okay, so you don't need 5 values with square root. Usually 3 or 4 are good enough. Okay. All right. So now let's go ahead and graph. These are all of my points: 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. Okay. So I only drew right like the positive xy axis here because I don't need any numbers on the left side. Okay. So I start here at my origin 0, 0. And let's plot everything else. 1, 1, 4, 2, and 9, 3. Okay, I'm not going to plot 16, 4 because I don't have the space. Okay, all right. So if you remember the shape, right, from Desmos, that seems to fit kind of what we had. Okay, so it is half of a parabola on its side. Okay, so it was on the S back prep, yeah. Yeah. Okay, I know it's not a great drawing, but there it is. All right. Okay, now notice this is considered my starting point, right? Notice that the function does not go to the left of that point, and here's why. Okay, algebraically, if I were to pick a number that was on this side of 0, let's say I picked -1, and then I take the square root of -1, can we take the square roots of negative numbers? No. What do they become? Imaginary. Yes, they become imaginary numbers. They're no longer real numbers. So, because it becomes imaginary, I cannot plot imaginary numbers on this graph. Right? We talked about this with quadratics as well. Right? Quadratics have, when we solved for the root of a quadratic, when we were looking for x-intercepts, we got imaginary number and we couldn't plot it. Same idea here. This means that -1 does not belong in the domain. Right? It's not a valid input. So, okay, if you get a value that's imaginary when you plug it in for x, then you're not going to plot it. That's why the function ends here. Okay. All right. So now let's take a look at what the domain and the range would be. With the square root function, you have to find the domain. It is no longer all real numbers because the function only moves in one direction, right? So I cannot say that the domain is all real numbers if I can't even include -1, right? And I can't include -2. All of the negative numbers can't be included in the domain. So we're looking to see how far left to how far right. In this case, what's the furthest to the left that we can go? It's 0, right? So starting at 0 with a bracket, since we can include it, all the way to positive infinity, right? Because it's moving to the right. Okay, so domain is from 0 to infinity. Okay. The range, still the same thing. Reading it from the bottom to the top. So the lowest value I have is still, it's also 0, okay? Okay. Why would it stop at 4? It's infinity, right? It stops at 4 on my table, but I could still use more inputs, right? So you want to read it as, well, it's rising. Even though you see it primarily as it moving to the right, the function is also coming, it's also growing, right? It's going up, right? So it doesn't stop anywhere, it keeps going, so the range also ends at positive infinity. Yes? Yes. With some variations, if it gets reflected, right? It might reflect across the y or across the x-axis. But it essentially should be, you could draw a full parabola and then cut it in half, and that's what your square root function looks like. Okay? All right. Questions so far? Yes?
So we're not allowed to put a negative number as a domain?
In this case, no. Because when I tried it, I would just simply substitute this value inside the square root for x, and I can't take the square root of negative numbers. Okay, because then they become imaginary, and I can't plot imaginary numbers on the real XY plane. Okay. Anything else? In some cases, you will be able to plug in negative numbers because eventually it turns the inside into something positive, which you can square root. Okay, so it just depends on what's going on inside. Okay. Questions? Yes, it can. Right. If there would have been a negative outside, right? Then what it does is you take the square root of the number and then you multiply by negative. So then all of these values would actually be down here, right? So you would have essentially like the other half of the curve, right? It would flip around. So it can be flipped. Yes, we'll see that. Anything else? Oh, that was like make it. Okay. All right, moving on. Next function, right? Let's start off kind of simple here. So before we do anything, right, let's talk about the transformation that takes place so that we can start to create that mental picture from the parent function. How would this one be different from that? Yeah, what happens? Yeah, horizontal shift 2 units right. It's still the opposite of what we see inside. Okay, so horizontal shift 2 units right. Okay, a quick note. I use HS so that it doesn't take me more time to write it on here. When you guys do it on your quizzes, you guys need to write out horizontal shift. Okay, that happened on a few quizzes where you guys did the shorthand version. I get what you're saying, but I need you guys to write it as like horizontal shift. Okay, because if you do HS and somebody else reads it, they're like, what the heck are they talking about? What's HS? Okay, so I just do it shorthand just to be able to write it down quick. Okay, but on your quiz, say the whole phrase. Okay, so it's a horizontal shift 2 units right. The shape should still be kind of like this, right? But it's going to move over 2 spaces, right? That's essentially the idea. So if we're looking for a starting point, whoa, why did this move? Okay, what would our starting point be? 2, 0. Yeah, 2, 0. Since there's nothing outside, right, we could use that as a 0. Okay, it's like saying +0 out here. Notice that I like to do something here when I draw my square roots. I don't know if I mentioned this before. I like to draw like a little tick mark down here to indicate what's inside versus what's outside. Okay, a lot of times I've seen students kind of confuse it where they draw the line a little bit too long and they accidentally include what's outside as what's inside. Okay, so I like to differentiate it by drawing a little tick down. So that tells me -2 is inside, whatever else would be outside. Does that make sense? It's just a way to kind of differentiate it. Okay, because I'll show you what I mean. Some people are a little bit less careful and they just kind of do that. And then you can't really tell what's inside or what's outside of the square root. That makes sense? Okay, so be careful when you're drawing it or when you rewrite it, right? It's when you guys rewrite things that some mistakes happen. Just draw a little bit of a tick mark down to indicate that it closes. Okay? All right, so before I begin, okay, I know my starting point. I want to do something usually that we do at the end. I want to do it at the beginning, which is I want to find the domain of the function algebraically before I start picking more values to plug in here for x. Okay, in this case, it's a little bit more simple, but in other cases, when you have reflections and you have negatives inside, it becomes difficult to understand what x values can I actually pick that will work. So what I want to do is I want to find domain algebraically. What do we know about square roots? The number that eventually gets cleaned up inside, what do we want that number to be? Positive, what's the worst case that it can be? It can't be negatives. So the worst case could be? It could be 0, right? So it can be 0 because we can take the square root of 0, it's still 0, or it can be any positive number. So I want x minus 2 to end up being greater or equal to 0. That will work because I can take the square root of that number. All right. So when you're looking for a domain algebraically, what you do is you set up the inside, which is just this piece. X minus 2, you want this to be greater than or equal to 0. Okay. When you solve it, then it tells you what x values you're allowed to pick. Okay. So in this case, if I solve it, then I simply get x greater than or equal to 2. So my domain has to be numbers that are equal to 2 or bigger than that. I can't pick numbers that are smaller than that. For example, a number smaller than 2, if I plugged in 0 here, 0 minus 2, I get square root of negative 2. That's imaginary, right? So I can't use that. That's not a valid input. So I have to pick numbers a little bit bigger than 2. Okay, so I know that my starting point is 2, 0. Okay. And for the rest of my domain, I want numbers bigger than 2. Okay. What would be another good input? So when I plug it in and subtract 2, I can take the square root of that. 6, 3. Okay, let's try 3, then we'll try 6. So if I take 3, now I'm going to have the square root of 3 minus 2, right? Which is the square root of 1, which still gives us 1. You said 4? You said 4, right? Why would 4 not be a great input? Square root of 2, and do you know it? Yeah, it's a decimal, right? We don't really know it. Okay, so skip it, pick another number. 6, right? So we can pick 6. Now we have square root of 6 minus 2, which is square root of 4, which is 2. Okay, let's find one more. What would be another good value to pick? 11. Yeah, if you pick 11, 11 minus 2, that becomes square root of 9. And we know square root of 9, right? We know that it's 3. Okay, so with square roots, you want to be a little bit more selective about what you select for your domain or your inputs because it just makes it an easier process. Okay. All right, so let's go ahead and graph. I have 2, 0 as my starting value here. Then we have 3, 1. Then we have 6, 2. And 11, 3 doesn't fit on my page, so I'm just going to leave it at 6, 2. Okay. All right, so now draw that half parabola on its side looking shape. Oh, that's terrible. Try that again. Okay, there it is. So now let's find domain, let's find range. What would my domain be in this case? Where would it start? Starts at 2, right? So you can even use it algebraically to help you, right? You know that 2 would be the smallest number and then everything has to be bigger than that. So on the graph, right, 2 is our starting value there, bracket 2, all the way to infinity, right? It's moving to the right. Okay, and then range, 0, right? We're looking for y value, that's the minimum y value, so from 0 up to infinity. Yeah, because it's rising, it's increasing. Okay. Okay. Any questions so far? How we doing? Okay. All right. Ready to move on? Yes. All right. Let's go. Okay. Gets a little more interesting now. All right, so before we begin, right, before we start with a starting point or a t-table, let's look for the transformations here. Okay, what would be the transformation in the correct order?
Horizontal shift.
Correct order. Horizontal shift, which way? Where? Left. Let's go left, right? When you do the transformation, you still follow it in the order that you know, right? So it's plus 2, so you're actually going left, right? So we start with horizontal shift, 2 units left. Okay, and then what happens? X-axis? Y. Y. Yeah, because the negative is inside the function, right? Okay, so then if we have a reflection across the y-axis. Whoops. Okay, so let's try to understand what this picture is doing. Let me slide this over. You start here, parent function, you move 2 units left, and then you reflect across y-axis, so now you're going to be doing something like this. Right, so why did I start where? Here? That's the parent function. Right? So the shape of the parent function would start here. Right? Then I move 2 units left, 1, 2, right? But then I'm reflecting across the y-axis, so I have to flip around this way. So now I should be ending up something like that. Right? Okay. So you understand, right? Like that the graph will now kind of be opening up to the left. Okay, now let's look for the domain. Right, let's look for what values could I actually pick here to plug in that would actually help me get positive numbers inside, and then I can take the square root of that. Okay, so let's find that algebraically. I'm going to set what greater than or equal to 0.
0.
I know I'm going to set it greater than or equal to 0. I want to know what. The inside, right? The inside of the square root, that's what we set greater than or equal to 0. So that becomes negative x plus 2 greater than or equal to 0. Negative 1. Are you saying that would be a good number to use?
Yeah.
It will be part of a domain that we can use. Okay, so let's just find the entire range first. So here you just solve for x, right? So first we subtract 2. Negative x greater than or equal to negative 2. In order to get rid of this negative, we divide both sides by negative 1. And what happens to my inequality when you divide by negative? Yeah, it flips it around, right? So now x is less than or equal to 2. So now all of the valid domain values have to be less than or equal to 2, right? So you're actually going to be picking numbers on the left side now, okay? So like I said before, just because it's just because you don't want negatives in here doesn't mean that you can't use negative inputs, okay? The reason why is because this negative out front of the function is going to help take care of those negative numbers, flip them back to positive, okay? All right. So, using what we know about our transformation, okay, and our domain, what would my starting point be for this function? Would it be negative 2, 0, or would it be 2, 0? Why 2, 0? It's a special case. We talked about this last time. There's a reflection across which axis? Y-axis. So when there's a reflection across y-axis, what's the two-word combo that we use? It's a keep, right? Because this caused us to flip across. So now that starting point, which normally would have been here, got flipped across to the other side, right? So now it's actually at 2, 0. So you keep it 2, 0, okay? So starting point, okay? That's why I want you to do the transformations first so that you remember that if you have a reflection across y-axis, you use a keep, and you know where to put that starting point, okay? So 2, 0 is where you start, okay? Why is there an R here? Oh well. Okay, so now let's think a little bit ahead. 2 is the largest number I can use. Every other number than that has to be less than 2. What would be another good value to pick for x here so that when I plug it in, I still end up with a positive inside and I can take the square root of it? 1. Let's try 1. Okay, so if I plug in 1, now my function is going to say negative 1 plus 2, okay, which is square root of 1, and I get 1 as an output. Okay, what else can I use? Should I use 0? No, because what do we get inside? Square root of 2, right? Negative 2, let's try, yes, negative 2. Okay, so careful here because you have multiple negatives that you're playing with. So the 2 is negative, and then you have a negative that's part of the function. So that's going to become negative, parentheses, negative 2, and then plus 2. So inside, right, you distribute this negative first. That's negative times negative. That's positive 2 plus 2. So you get square root of 4, which then gives you 2. Okay. Do we all see how I got that? All right, just distribute this negative first. Then you can add square root of 4. Okay, what else? Let's get one more point. -7. Yeah, let's try that. So -7. So that'll be negative times -7 plus 2, which gives us positive 7 plus 2, which is square root of 9, which is 3. Okay. All right, so that should be good enough, right? So let's go ahead now and move over to the graph. So let me write out these coordinates. I have 2, 0, I have 1, 1, -2, 2, and -7, 3. Okay. All right. So starting point at 2, 0. Then I have 1, 1. Then I have -2, 2. And 3, 4, 5, 6, 7, 1, 2, 3. And there's my last point. Okay. And so that's kind of what we anticipated, right? When we were modeling what would happen with the function, right? We knew that it would flip across the y-axis, so now it's moving to the left. Okay, that makes sense. So now let's go ahead and sketch that. There it is. Okay. Questions so far? Okay. All right. So now let's take a look at the domain and the range here for this function. What would my domain be? How far left does it go? Yeah, negative infinity, right? It keeps going over here. So from negative infinity to 2. Yeah, exactly, right? Not 0, but 2, since that's our x value, so we use that. That's 2. And then our range. What's the lowest y value we have? It's 0, right? I know it's like it's almost trippy to look at because it's moving to the left and you're still just trying to measure like down, like bottom to top, okay? But try to train your eyes on just like what's the lowest point of the graph versus where is it going, right? So the 0 is the lowest value. Now, even though it's moving to the left, is it moving up? Yeah, it is, right? It's still rising, okay? So you don't care about the fact that it's moving to the left because we already took care of that with the domain. So we only care about, yeah, so up towards infinity, okay? Even though it's moving left, it's still moving in the positive direction for the y values. So from 0 to infinity, okay? Does that make sense here? For the range. That's the trickiest part because you're going to want to look at this as moving to the left, and guess what a lot of you are going to say here? You're gonna want to read it as like a domain. But the fact that it's moving up, right? Look at your y values on your table, right? It goes from 0 to 1 to 2 to 3, right? The y values are increasing. So that's how you know it's moving from 0 to positive infinity. Okay. All right. Questions there? We're okay? All right. Let's get into a little bit more complex stuff here. All right. We'll do one more together, and then I'll set you off to do the last one on your own. Okay. So walk me through this. I kind of give you a couple hints here. I want to start with transformations. Yes, is that the first one? What would be the first transformation though? Yeah, 1 unit to the left, horizontal shift. Okay, so okay, that's 1. Second transformation, what happens? Focus. Is it reflection? It's a stretch, right? Why is it a stretch? Yes, the value of A, right, is greater than 1. Right? So we know that the 3 is going to cause this thing to stretch. So we have a vertical stretch by a factor of 3. Okay. Then what? Not yet. Reflection, right? Then we take care of the negative, right? So that's a reflection across which axis? X. Yeah. And then finally, then it's a vertical shift. Which way? Up. How many units? 5. Okay, so vertical shift, 5 units up. Okay. Okay, so we have an idea of what's happening, right? It's gonna reflect, stretch, all that good stuff. Okay, now before we move on, find that starting point. Okay, I want to try to find the domain algebraically here without, without having a graph. Okay, so what am I gonna set to be greater than or equal to 0? Yeah, whatever's inside the square root, which in this case is only the x plus 1. Okay, I don't want anything else because that doesn't affect the domain. All right, so just this piece here. Okay. So then we solve, that's going to tell us that the domain is just going to be anything that is greater than negative 1, okay, or equal to negative 1. Okay, all right. So there's domain. Now we can find starting point. Did we have a reflection across the y-axis? No. So then how do we find the starting point? It's opposite keep. Good. Okay, so SP, starting point, we can use, what would it be? It'd be negative 1, 5, right? Because we can follow opposite keep. So opposite of 1 is negative 1, comma 5. All right, so negative 1, 5, starting point. Okay, all right. So now let's think. Okay, I want to make sure that whatever number I get, I don't care about what's happening on the outside. The outside will take care of itself. I just care about what numbers can I plug in here so that when I add 1, I can take the square root of that number. You want to use 1? You want to use 3? Before we use 3, let's use 0, right? Because 0 plus 1 gives us 1, and square root of 1 we know. Okay, so let's use 0. So now we have negative 3 times square root of 0 plus 1, and then after that we add 5. Okay, so the process here is clean up the inside first. We know that that's going to be the square root of 1, and the square root of 1 is still 1. Okay, so then what do we do with that 1? We multiply it times negative 3. Okay, you don't add, don't do that stuff. Okay, so then this becomes negative 3 times 1 plus 5. Okay, so that's the same thing as negative 3 plus 5, so we get positive 2. Okay. What would be another input? Then that would be 3, right? Let's use 3 now. So we have negative 3 square root of 3 plus 1, and then plus 5. Okay, so that gives us negative 3 times, okay, this then becomes the square root of 4, and the square root of 4 is 2, so then that becomes simply negative 3 times 2 plus 5. Okay, so that's negative 6 plus 5, so we get negative 1. Okay, let's use one more input. What would be another good one? Yeah, let's use 8. Okay, so then that gives us negative 3 times square root of 8 plus 1 is square root of 9. Square root of 9 is 3. So that's essentially the same as negative 3 times 3 plus 5. Do you see how I got to 2? Yeah. I know, I'm like skipping a step there. So then negative 9 plus 5, that's negative 4. Okay. Okay. We can stop there, that's fine. Because then we'll have to go up to like 15, and that's probably not going to fit. Okay. All right, let's graph Alright, so starting point, negative 1, 5. It's up here. Okay, then we have 0, 2. Then 3, negative 1. And then 8. And then down 2, 3, 4. Okay, so like way down here. Okay. Alright, so remember this is starting point up here, so you want to start from there and then you draw your arrows. You draw your line with the arrow coming in this direction. Okay, so okay, there it is. Okay, so it looks so like wide because it got stretched, right? It got pulled, so it doesn't look like as traditional as our parent graph. Okay. Then it also got reflected, right? So the reflection causes it now to be going down, right, underneath. Okay. All right so far? Yeah. Okay. All right, so now domain. I feel like domain is actually the easier one to find on these functions. What would it be? Where's our starting value? Negative 1, right? So start at your starting point. That's negative 1. All the way where? Infinity, right? Because we're moving in the positive direction along x, right? So just along x, it's moving to the right. Okay, it doesn't matter that it dipped underneath. Okay, so from negative 1 to infinity. And then your range. Yeah, why negative infinity? It's going down, right? So you're reading it from the bottom to the top. So from bottom, it's going to be getting close to negative infinity, so we start there. And where would it stop? Yeah, it goes up to 5, right? That's the highest value. So from there, we can say negative infinity up to 5. All right? We're okay? Good. Okay. All right, so now this next one, I want you to try on your own. Anybody still copying? No? All right. So next one, here's the process that I want you to go through. Okay, I want you to write out the transformations first. Okay, do the transformations. After you do the transformations, I want you to find the domain algebraically. Okay. Find your starting point. Draw your t-table. Graph it. Domain and range. Okay, in that order specifically. Okay, so go ahead and work with each other, help each other out.